Okay, guys, let's take a look at the Chapter 3 extra practice in the back of the textbook. For problems 1 through 6, it says classify the angle pairs corresponding, alternate interior, alternate exterior, or consecutive interior. We're going to be using same side interior. So let's take a look at number 1, angle 6 and angle 2. Right? Now in this case, the lines are not parallel. They don't have to be. But angle 6 and 2 are in the exact same position at each of these two intersections, here and here. In fact, if we had a compass with this being north, east being this direction, they'd be in the northeast side of, again, the way I like to look at it, is streets if you were walking up the street. So angles 2 and 6 are corresponding. All right? That's what we're looking for here. And that's somebody's favorite type of angle. Now, take a look at number 2. Number 2, it says angle 7 and angle 2. Well, let's see how angles 2 and 7 are related. Well, they're both exterior. They're both outside the two lines that are marked here. All right? So this is exterior to those two, and they're on opposite sides of this transversal that's cutting across. So these are going to be alternate exterior. Let's go to number 3, angles 5 and 3. Let's take a look at these two. Here's 3, here's 5. They're on the same side of that red transversal. They're also in between these two lines, so they're interior. So again, I'm going to call these same side interior, which again is what you'll see in most textbooks and standardized tests. Right? Now then, let's erase some of this stuff and let's take a look at number 4. Number 4 is looking at angles 4 and 5 together. So here's 4, here's 5. Those two angles. Now these are different angle measures, which all of them have been because the lines are not parallel. But where are they? They're interior. They're in between the two lines that you see that are being cut, and they're on opposite sides now of the transversal. So this is alternate interior. Instead of exterior, these are alternate interior. Well, let's take a look at angles 1 and 5. Here's 1, here's 5. Again, looking at the compass, this looks like northwest side of these intersections. So these are, again, corresponding angles. Well, let's take a look at the last pair for number 6. Angles 3 and 6. Let's put these right here. Well, again, those are interior in between the two lines. They're on opposite sides of this transversal. So again, that's another pair of alternate interior angles. And you have to be able to go through and spot what angle pair types. Once we have lines that are parallel, then you can actually say something about them. But for right now, we're just having them named. All right, let's take a look at problems 7 through 11. With this diagram, and you can see it there in your textbook a little better. Mine's a little low. It says the measure of angle AMB and another angle are corresponding. Well, I'm going to mark this angle AMB right here. And again, that looks like the northwest side. I'm just going to continue down this line AD. So this is the transversal until I get to the next line, which is CF. And here is an angle in the same position right there. So if I'm naming that angle, I'm going to say angle CJA. Angle CJA. Now that's one corresponding angle. But let's take a look at this other scenario. and I'll have to bring this up just a tad. That's good right there. Here's angle AMB again. But now if we start going down this other transversal, say BG, and instead of going across left to right, let's go down. Well, when we get to the next line, HE, we have another angle in the same position. So I would say angle BLH. Both of these two angles are corresponding with angle AMB, right? Now CJA and BLH are not corresponding with each other because they're not on the same transversal. But CJA corresponding with angle AMB. BLH is corresponding back to AMB. So those are the pairs that we have there. Well, let's take a look at some others that they have listed. Next pair is alternate interior angles. Well, angle AML. So let's take a look. AML right here. Well, again, if we want to be alternate interior, it's got to be in between two lines. This is in between line AD and line HE. That's the interior part. And alternate means it has to be on opposite sides of the same transversal. So I'll mark this as BG again. Well, this then, angle BLE, that is alternate interior with angle AML. There's not another angle that angle AML is alternate interior with. Okay, so that's the only one that we can use in this situation. Let's take a look at number 9. For this one, it's asking for alternate exterior angles. Well, the original angle is CJD, so I'm going to mark it over here. There's CJD. Well, it's got to be alternate exterior. Let's take a look at this transversal, CF, and the two lines, AD and HE. And again, this has got to be on opposite sides. Well, opposite sides of this red transversal, and on the exterior means it has to be touching the line, but in this position. So angle HKF. That's one possibility. But let's take a look at the other pair of lines now. Take this one off. Look at these two red lines. And now then let that blue line up top, that AD, be the transversal. Well, we have another alternate exterior over here. And so we would say angle AMG. Angle AMG is also alternate exterior with that original angle CJD. Now remember, these two in red are not alternate exterior with each other necessarily. It's just CJD and angle HKF are alternate exterior, and also angle CJD and angle AMG are alternate exterior angles. Let's keep moving. Consecutive interior, again, I'm going to call those same side, as most texts do. But we've got to find where they are. Well, the first angle is angle LMJ. It's this one right here. Well, if you want to be on the same side, it's the same side of a certain transversal. I'm making this line right here the transversal, which gives me two lines here in blue that it's crossing. So the other angle has to be on the same side, and in between, that's over here. And so I'd say that's angle AJF. So angle AJF is one possibility. And that's supposed to be an F, not an E. Angle AJF. That's the first one. Well, again, I'm going to draw this red line here for HE, and I'm going to get rid of this other side and let the blue be the transversal. Well, now then, if you look where this angle LMJ is located, there's another angle right here that's interior to the two lines that look like they're almost horizontal, and it's on the same side of the blue transversal. So this is angle BLE. So angle BLE again. Now, take a look at number 11. It says this is a transversal of lines AD and HE. Well, here's AD again, marking it in red, and here's HE. Well, we got two transversals. We've got this transversal here, so I'd say line BG is a transversal, and again, that's a line, so I have the arrows on either side. Or line CF. Here's another transversal, and these are the two lines that are crossing line AD and line HE. So there we have problems 7 through 11. Let's go on to problems 12 through 14. It says on these, find the measures of angle 1 and 2 and explain your reasoning. Now we're going to explain the reasoning maybe more than one way, but I'm going to take a look at the angle that's given, and that's this 136 degree angle here. Okay? Now, what I would like to do is use one of the angle pairs that we have corresponding alternate interior, alternate exterior, or same side interior, instead of having to go multiple steps. Now, the angle 136 and angle 1 over here, that's not corresponding. It's not alternate interior, it's not alternate exterior. It is the same side exterior, but we didn't really study that one, so I'm going to use something else. I'm going to go to this angle 2. This angle 2 and the 136 are alternate exterior angles. Here's the transversal. The lines that are parallel, and you know they're parallel because they're marked as being parallel here. Alternate exterior angles are congruent. So the measure of angle 2 is 136 degrees. Well, now that we know this angle, angle 1 and angle 2 form a linear pair. A linear pair is a pair of angles that form a line. They're both supplementary and adjacent. So if I subtract 136 from 180, this is going to give me this angle up here, and 180 minus 36 is 44 degrees, and that's the measure of angle 1. So the measure of angle 1 is 44 degrees. The measure of angle 2 is 136 degrees. And so we actually solved for angle 2 first, and then we solved for 1. Let's go on to number 13. Again, our lines are parallel. If they're not parallel, we can't say anything about any of these angle pair types as far as being congruent or supplementary. But let's take a look at this 68. Here is angle 1, and these are alternate interior angles. And because the lines are parallel, alternate interior angles are congruent. Well, once you know angle 1, again, a linear pair right here with angles 1 and 2, this has to be 180 minus 68. Well, 180 minus 68 is equal to 112 degrees, and this is what we're looking for angle 2. Okay? Now, let's go on to number 14. Okay, again, parallel lines. We know that to begin with. Well, let's take a look. Angle 1 and this angle 106 right here. What angle pair type are they? They're corresponding angles. Corresponding angles are congruent. So this also has to be 106 degrees. Once you know angle 1, you have to know angle 2 because these are vertical angles to each other. So this also is 106 degrees. Now, if you look at the 106 degree angle and angle 2, those are also alternate exterior angles. So that's another way that you could say how you found the measure of angle 2. But for me, once I find angle 1 corresponding, did that first, I'm using vertical to find angle 2 because vertical angles are always congruent. Let's go on to number 15. On these, it says find the values of x and y. Again, parallel lines. That's given. So I've got to go through and figure out something from the angles that are here. Well, this 81 degree angle and this angle over here are alternate interior angles. Alternate interior angles, when the lines are parallel, are congruent. So I'm going to write down 81 is equal to 9x. Dividing both sides by 9, 9 is equal to x. And the directions are solve for x and y, so I can stop here. But again, if we plug it in, we get 81. Well, if we know that that's 81, look at this angle right here. Well, that angle and the original 81 are a linear pair. They're adjacent and supplementary. They have to add up to 180. So I'll write down 100 minus y plus 81 is equal to 180 degrees. Now, combining like terms, that's the 100 and the 81. That's 181 minus y is equal to 180. Subtract 181 from both sides. That's going to be negative y is equal to negative 1. Then multiply both sides by negative 1. Y is equal to 1. So we have our value for x. We have our value for y. Number 16. We have a trapezoid. Trapezoid has one pair of opposite sides parallel. We've got that. Well, let's solve for x first. Here we have a segment between these two parallel lines. And this angle up top is marked as a right angle. Well, if that's a right angle, if you've got a segment that's perpendicular to a one parallel line, it's got to be perpendicular to the other parallel line. So I'm just going to say that 3x is equal to 90. So dividing both sides by 3, x is equal to 30. Now, if you wanted, you could say that this angle here and this angle here are same side interior angles. Same side interior angles, when they're between parallel lines, are supplementary. So you would say 90 plus 3x is equal to 180. And as soon as you subtract 90 from both sides, you have 3x equals 90, which is what we had for our first way of solving it. Well, we also need to solve for our y values. So now that we know that x is equal to 30, we'll go through and say something about these two angles here. Well, these are on the same side of this transversal. This is the line that's cutting across the other two, and the lines are parallel. Same side. This is the one that's different. It's not congruent. It's supplementary. So we don't set them equal to each other. We add them together and say that their sum is 180 degrees. Do that first. Now then, we need to go through and combine our like terms. So the 13y plus 5y, that's 18y. Well, then taking the 5 and the negative 5, well, plus 5 minus 5, that's just 0, is equal to 180. So we have 18y is equal to 180. Dividing both sides by 18, y is equal to 10. So x was 30, y is 10. Let's take a look at the next set of problems, skipping 17. Is there enough information to prove that line M and N are parallel? So we're looking at these two lines. Are these lines parallel? Not the ones that look horizontal, right? Well, let's take a look. We've got these two angles, this one and this one. Are they one of our angle pair types that we've studied in this chapter? Well, are they corresponding? No, they're not. They're not in the same position. This top one over here on the left, it's on the southeast side. This other one is on the northwest. That's definitely not in the same position. Are they alternate interior angles? Well, they're definitely interior between both pairs of lines, M and N, and the horizontal looking ones, but they're not on the same transversal. They're not on the same, so they're not on alternate sides. In fact, that's the problem with these two angles. They are congruent, but they're not on the same transversal. And all of these angle pair types that we've looked at have to be on one single transversal. We've got two different ones. We've got this bottom one that I'm marking in green, and we've got this top one that I'm marking in blue. So that's not enough information to say that M is parallel to N. Let's take a look at 19. Now here we have two angles that are both marked as right angles. Well, now, our lines M and N, here's one, here's the other, and we have a single transversal that both of these angles are on. They're both perpendicular to the same transversal, the same line. So in this case, line M is parallel with line N, because any lines that are cut by a transversal and are perpendicular, both of them, to that same transversal, they have to be parallel. Let's take a look at 20. Now for 20, I'm going to do things just a little bit differently. I see that the lines are parallel. Those two lines are parallel. I'm going to go through and mark everything that I can possibly think of that I know from all the angles that we've been given. So I'm going to start with a 71-degree angle over here. And I'm just going to say, well, I got parallel lines. This angle is also 71. Why? Because those are alternate interior angles. Well, I also know this angle with the original 71. This is a pair of angles that are same side interior. Same side interior angles have to be supplementary. So the supplement of 71 degrees, the angle that adds up to 180, this has to be 109. Well, if you notice up here at this intersection that I'm marking in red, see, there's an intersection of two lines. Well, as soon as we have that, we have different pairs of angles, linear pairs and vertical angles. So I'm just going to mark the vertical angle here with 71, the vertical angle here with that 109, and notice we got four different pairs of linear pairs here. The top right, the bottom right together, that's a linear pair. In fact, you go all the way around, you take any two consecutive angles, and they're going to be a linear pair. Well, let's go to the other transversal and do the same thing. Here's this 109-degree angle. I'm going to take this angle directly across this vertical angle and say that's 109 degrees. Well, again, we can fill in the other two because these are going to form linear pairs. So this is 71 and so is this. Well, now that we have both angles on the interior side on the left, I can also say this is alternate interior, and this angle is also alternate interior with a 109 degree angle. So we've filled out every single angle that we can. Are lines M and N parallel? Absolutely. Let's take a look at this pair right here. Those are alternate interior angles. Alternate interior angles force lines M and N to be parallel. Or we can look at this pair of angles, the 109 and this 109. Those are corresponding angles. In fact, we could go around both of these intersections left and right on that top line, and we're going to have 4 different pairs of corresponding angles that are congruent. So this one has a lot of methods where you could go through and show that lines M and N have to be parallel. Now, for 21, can you prove that these lines are parallel? Well, the two that we're wanting are these two over here on the right. Can you prove that these two lines are parallel? Well, absolutely. You see these two angles here and here, this one and this one. Forget about all the rest of this stuff over here, which we don't need. It's just there to confuse you. What angle pair type are these two on this one transversal? Well, that's alternate interior angles. Because alternate interior angles are congruent, lines A and B have to be parallel. Let's take a look at 22. Now we're given some numbers. Well, let's go with probably the easiest way. This angle, they're congruent. What angle pair type are they? Alternate interior angles. Because alternate interior angles are congruent, lines A and B are parallel. Is that the only way to do it? No. We could also take this angle and this angle. Now these are different, but notice they're on the same side of that transversal cutting across lines A and B, and their sum is 180. They are supplementary. Because same side interior angles are supplementary, lines A and B also have to be parallel. So again, various ways that we can show that A and B are parallel. Let's move on to the next problem. Well, now this one's a little bit tougher. We have a whole lot of angles and we got a lot more transversals drawn. Now again, the stuff that we don't need, we don't want to mess with. The two 26s that are here, we really want to bite on those because that's going to say that we do have a couple of lines that are parallel, but it's this one and this one. Alternate interior angles do make these two lines that look horizontal be parallel, but that's not the pair that we're after. So that's useless for us. But let's take a look at something that will help us. This angle over here, the entire angle. Notice that they've got this 101 on the top side, the 26 on the bottom, but if we add them together, we have an angle of 127 degrees. Angle addition postulate says we can add them because they're adjacent angles. We can add them together. And so we get 127. Now then, look at this 53 degree angle down here. Because if we look at this transversal cutting across this way, again, the rest of the diagram is there to confuse you, make it harder to see. But do you see that this 53 plus 127, the sum of these two is 180 degrees. Because they are supplementary, that means line A and B now are parallel because we found one pair of same side interior angles that was supplementary. Well, let's move on to section 4, and here we have the directions. Tell whether the lines through the given points are parallel, perpendicular, or neither. Well, let's review very quickly what it means to be parallel. Parallel, if you have two lines and their slopes are the same, well, that's parallel. Perpendicular means that if you have two lines' slopes, the slope of one is the negative reciprocal of the other. Now that formula is hard to see, but we're going to go through and see if these are parallel. If it's neither, it's not the same, that would be parallel, or not the negative reciprocal. Let's just see what happens. Number one, we have to be able to find the slope given 2 points. So let's use the formula now, since we don't have a graph. y2 minus y1 divided by x2 minus x1. Remember, the definition is rise over run, and I would use that if I had a graph. Now, if you don't remember the formula, you can go through and graph these and count up and over the rise versus the run and find that slope. But if you don't have the graph, sometimes that takes a little bit more time to go through. So I'm going to use it without. But again, if you don't remember, all right, don't remember that formula, use the graph, use the definition, because that will always work. So I'm going to say m sub 1. This is my line 1 slope, which is why I have the m sub 1, is equal to y2. That's going to be the 5 right here minus my y sub 1, which is the 4. All of this is divided by, well, I've got to get x2, that's 10, minus my x sub 1, and that is the 7. So when we simplify both numerator and denominator, 5 minus 4, that's 1. 10 minus 7 is 3. So that's the slope of the first line. Slope of line 1 is 1/3. What we're looking for, if it's parallel, we want the slope of line 2 to also be 1/3. Or if it's perpendicular, the negative reciprocal, we'd be looking for negative, because this is positive, negative 3 over 1. Negative 3. Well, let's see what we find. Let's take the slope of the second line. And again, this will be y2. I'll just take it now, 5 minus 3 divided by x2, which is 8, minus x1, 2. Let's see what this simplifies to. 5 minus 3 in the numerator is 2. 8 minus 2 in the denominator is 6. 2/6. But notice these both have a common divisor of 2, so we can write this as 1/3. So the slope of the second line is also 1/3. Because these two lines have exactly the same slope, this is parallel. So lines 1 and 2, in this case, are parallel. Well, let's go on to the next one, number 26. Skip 25. 26, we have to do the same thing. So I'm going to find the slope of line 1, which is going to be 7 minus 0, that's y2 minus y1, divided by 8 minus a negative 6. Minus a negative is a positive, so that's 8 plus 6 in the denominator. That's 14. The numerator is just 7 minus 0, which is 7. And this simplifies to 1/2. So the slope of line 1 is 1/2. Let's take a look at line 2. Again, if it's going to be parallel, we're expecting another 1/2. If it's going to be perpendicular, we're expecting negative 2 over 1, the opposite reciprocal of 1/2. Let's see what we get. Let's see, y2, that's a 2, minus y1, that's 4, divided by x2, which is 2 again, minus x1, which is 1. 2 minus 4 in the numerator, that's a negative 2. And 2 minus 1 in the denominator, that's a 1. This is negative 2. And so look what we have. The slope of the second line is negative 2, or 2 over 1, which means these two are perpendicular. Their slopes are negative reciprocals of each other, so they have to be perpendicular. Now, take a look at problems 27 through 29. We're not going to do any of these. It says, which line is steeper? Steeper means which one has a bigger number without the sign. You say the absolute value of that number. But which number is bigger? If you take the slopes of those two and compare them, whichever one is the bigger number, regardless of whether it's positive or negative, that's going to be the steeper. Because if you're coming down with a negative slope, that's still steeper, even though it's a smaller number. So you just look at the number without the sign. But let's go on to the next set of problems. And this says, write an equation of the line that passes through the point P and has the slope m, or is parallel to the line with the given equation. We're going to do even more than that. We're going to also do the perpendicular. So here's the line that's parallel, right? It goes through, slope is 2. Or if we want to say perpendicular, again, going beyond just the directions, we need to do both. A perpendicular slope, just like in the previous problem, would be the negative reciprocal of 2, which is negative 1/2. Now in this case, I think the easiest method is to use the point slope form. Point slope form, which our textbook didn't give us, but it's very nice on a problem like this. Y minus y1 is equal to the slope times x minus x1. We plug in the x and y coordinates for x1, y1, and we leave the y and x in. So I'm going to, for the line that passes through this point, just say y minus, well, I've got to take the y coordinate, which is 7. That's the only point that's given, so that's y1, is equal to, well, see, we don't have to figure out what the slope is because they gave it to us. It's a 2. And then x minus, well, my only point that's given here is 4. And so this is the equation in point slope form. This is one way to do it, and I like that. Let's take a look at another method that's also given in the textbook, and let's use slope-intercept form. Now this is the line that we started with in most of our algebra. Slope-intercept. The y equals the slope m times x plus, don't need the parentheses there, y equals mx plus b, where b is the y-intercept. Well, if you take both of the points, the coordinates for x and y, so 7 would be the y, is equal to the slope 2 the x value 4 plus b is what we don't know. Well, let's go through and solve this. 7 is equal to 2 times 4 is 8 plus b. Subtracting 8 from both sides, -1 is equal to b. As soon as you know what b is equal to, you can plug it in and you can write this equation as y equals the slope which was given of 2 times x, again, don't need parentheses now, plus a -1, which is the same thing as -1. So y equals 2x minus 1. That's a different look. It's a different look, but it's the same thing as if you were to take this equation and distribute the 2 inside and then add 7 to both sides. You get exactly the same thing. Now that is for the line that goes through there, that point, and is parallel or just that one line, right? If we were going perpendicular through that point to the line that was there, in point slope form, the only thing that we would have to change, again, this is for perpendicular, this is not one of the directions for this set of problems. The only thing that we would have to do is to take this -1/2 in point slope form and substitute it in here, and that would be a perpendicular equation of the line through that point. So that's another reason why I like the point slope form. There's less work to do, less work involved. Let's go on to another problem. 32, we'll just do the parallel this time. Here's our point, here's our slope. Again, I'm going to use y minus y1 is equal to m times x minus x1, our point slope form. Because I can just plug in y minus 4 is the y coordinate. Our slope now, -1/3, just writing that down, and then x minus 9. Now let's suppose we start with this, and let's say this is on a multiple choice question, and that answer is not showing up. That means they probably put it in slope-intercept form. How can we put it in slope-intercept form? Well, let's just go through and change it. Distribute the -1/3 inside this set of parentheses. That would be -1/3 x, and then -1/3 times -9. Well, the negative times the negative is a positive, and 9 times 3, or 9 times 1/3 rather, is going to be +3. Well, finally, to get y by itself, which is what slope-intercept form is, we've got to add 4 to both sides. So y is equal to -1/3 x. That doesn't change, but when you add the 4 with the 3, that's a like term. You have y equals -1/3 x plus 7. So you can take this point slope form and put it in slope-intercept form anytime that you need. It's just a couple of steps. Let's go on to one more problem from this set. Well, now they don't just give us the slope directly. It's in a line. Well, this line, y equals -2x minus 6, its slope is the -2. That's the y equals mx plus b. And all we need is the -2. That's the slope. So the slope now, -2. Now the problem's just like the previous two. We go through, we write out y minus, well, that's a -2. So we'll have to simplify that. Is equal to the slope, -2, times x minus the x coordinate for our point, 1. So this would be y plus 2 is equal to -2 times x minus 1. Here's point slope form. Well, again, if we need to change it into slope intercept form, go ahead and distribute the -2 that's outside the set of parentheses and have -2x. The -2 times -1 will be a +2. And then for the final step, subtract 2 from both sides. So y is equal to -2x. And when we subtract the 2's from both sides, that's it. So here is slope intercept. Here is point slope. If it doesn't ask you or tell you to put it in a certain form, leave it in point slope form. Why do more work? Let's continue with 37. Well, now 37, our slope is, again, the coefficient of x. That's 2/5. If we were needing perpendicular, we would use -5/2. But let's use the 2/5 and plug into our formula. Y minus our y coordinate 4 is equal to, again, because it's parallel, 2/5. Otherwise, we'd use -5/2 for perpendicular. And then x minus a -9, that's +9. And that's it. Again, if it doesn't say to change it, I'm going to leave it like that. Well, let's take a look at the next set of problems. Here, it says find the measure of angle ADB. Well, if you look at all these problems from 39 through 44, these all have for the outer angle a right angle, which means that the two angles on the inside of this angle, they're adjacent, but they're not supplementary, they are complementary. Complementary angles add up to 90. C comes before S on the alphabet, complementary before supplementary. 90 comes before 180 on the number line. So 90 goes with complementary, 180 goes with supplementary, and these are all complementary. Well, let's take a look then. This is 21 degrees. What do you have to add to 21 to get 90? Well, if you don't realize this is 69 degrees for this angle, all you need to do is take 90 minus 21, and that will give you 69 degrees. And that's the measure of angle ADB, which is what they're asking for in this set of problems. That is 69 degrees. Let's take a look at the next one. Well, angle ADB. Look at this. We've got two lines, line AD and line BD, and they are perpendicular because we see a right angle at this intersection, and perpendicular lines always form 4 right angles. So even though it's not marked, the measure of angle ADB has to be 90 degrees. And this is something that we know from our definition of perpendicular lines. They always have if you have one right angle, you've got 4 right angles. All right, let's go on to one last problem. Here we have some variables mixed in, but again, the sum of these two angles, these are different angles. They're not congruent. We're not going to set them equal to each other. We're just going to say 26x plus 3x plus 32 is equal to 90. The only time that we set these two angles equal to each other is if it says that this ray DB is an angle bisector. But it's not telling us that it's an angle bisector. It's just showing us that this is going to be complementary. So we have to set them, add together, equal to 90. Well, let's go through and combine our like terms here. 26x plus 3x, that's 29x plus 32 is equal to 90. Subtracting 32 from both sides. Well, that's going to be 58. And then dividing both sides by 29, x is equal to 2. Again, for this set of problems, it says find the measure of angle ADB, so we have to plug the 2 back in. Well, now remember, here's the angle, ADB. This is the one that they want. Don't plug into the other one mistakenly. Well, let's see. 3 times 2 plus 32, that's going to be the angle measure. 3 times 2 is 6, plus 32, that is 38 degrees, and that's the measure of angle ADB. Now, for number 45, we're not going to do that one here, but you can go through and fill in the parts of this proof, one line at a time, to go through and figure out what each of these need to be. All right? So look at the given information, look at the statements that are there, and go through and figure out one thing at a time what has to be there, what the reason is, or if they give you the reason, what the statement has to be, so that you can prove that the measure of angle ABD is 45.